Hey guys, this is FRQ 351. I'm going to walk through how to do it. We have a table, and it has height in square feet, and so we're not really sure where this is going with us because we don't this would be an original. That's kind of strange. Anyway, a tank has a height of 10 feet. The area of the horizontal cross section of the tank at height h feet is given by the function a. So this is the area, and so this is the height. So altogether, this times this would give you the volume, right? The function is continuous and decreases as h increases. So as the height gets bigger, the function a, the area, decreases. Select values for a are given. So the first thing it says is use a left Riemann sum with 3 subintervals by the data to approximate the volume of the tank. So that means we're going to use area under a curve, but we're going to use height as the width, and width as the height, this height, and area as the height of the curve. All right, so here we go. Left Riemann sum. So left would mean from here to here. It's 2, got to do this first, and then 3, and then 5. And left would mean this one, and this one, and throw that one out. All right, so we'll say the volume, for part A, the volume in the tank is approximately equal to 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5, which equals 176.3 feet cubed. Okay, you get 1 point in this one for all your units right. So I'm going to put +1 units, correct? So that would be for this feet cubed. So for what you get as far as the FRQ, this part A, you get 2 points for this part. 1 for that you use the left Riemann sum, so they would be checking that you use just the left-sided ones, and 1 for the answer. So +1 for the left Riemann sum and +1 for the answer. Okay, going on to part B. It says, does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Okay, so what I do for this is I look to see, we are decreasing right here, right? This is decreasing. So my function that I took the area was decreasing, and it was a left Riemann sum. So just start here and go, okay, I'm going to do some areas here, and I am going to do left-sided, so it would come here, and this one would go out to there, and this one would, using left ones. Hang on, let me draw it better. Okay, so left, I'm drawing this, 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 and this. If I'm going left, I have to go out to here and over, out to here and over, and out to here and down. And so you can see that it's going to be an overestimate. So we're going to say overestimate. Now the picture is not your answer yet, but you can say what's happening in the picture. Because A is continuous and decreasing, and we used a left Riemann sum. So that's worth 1 point altogether for the overestimate with reason. So sorry, I switched colors. Let's do this as 2 points. It's 1 point. No. +1 overestimate with reason. Okay, let's move on to part C. I'm going to do it up here. Part C says the area in square feet of the cross section is given by this function f of h. So we have this function right here, f of h, which is the area. Based on this model, find the volume of the tank, indicate the units of measure. So what they're saying is now they had a table, now they give us the function. And so we want it at the volume of the total tank, volume of the tank would be at 10. So you would just say the volume is equal to the integral of 0 to 10 of f of h dh, and that's equal to 101.325, and they want units, of course that would be feet cubed. Again, that's to get this 1 point for all things correct. So again, a little bit strange because we're using volume and stuff in the same way we used accumulation. So that was worth 2 points. So +1 for the integral. So this is +1 and +1 for the answer. And lastly, part D. Okay, water is being pumped into the tank. The height of the water, when the height of the water is 5 feet, the height is increasing at the rate of 0.26 feet per minute. So guys, write down what that is. That's dH/dt, right? The height of the water, it's a rate, is increasing. So dH/dt equals 0.2 h at h equals 5. So we can tell we're going to have a related rate. Says using the model from part C, so make, there's your function, right? Find the rate at which the volume of water is changing with respect to time. Okay, so what do they want? Okay, we want dV dt. Okay, but we don't have dV dt, we have dV dH. And then they gave us dH dt, so you guys, you can set up this formula for related rate. dV dt equals dV dH times dH dt. So that's really important that you understand this is a related rate. And, okay, so we know that we can take the derivative, dV dH is just the derivative. What is the derivative of V? So we would say that dV dH is equal to the derivative of d dH of the integral of A of H dH. That's dV dH, that's that, times dH dt. Well, let's just put what dH, that was 0.26. Okay, and so what is the derivative of this? It's from 0 to 5. It's just A of 5, right? Times 0.26. So if you stick in 5 for H in the formula, you get, so no integration necessary, you were just showing you take the derivative of the integral, and you should get 1.694 feet cubed. Again, units are important. Now, that was worth altogether 3 points. And so you want to have, if you got dV dt, okay, so dV dt set up right here, you get a point. Okay, you actually get 2 points for that and 1 point for the answer. Okay, so that should be 9 altogether, and that was FRQ 351.